This is Kosmographia, the Randall Carlson Podcast. And welcome back, ladies and gentlemen, to Kosmographia Podcast. We have all the usual suspects here. I am Russ. This is my brother Kyle. We are the hosts. We got Bradley, Randall, and Mike, the normal guy. How you guys doing?
I'm a suspect.
Usual one.
I must say I'm doing quite well myself. It's good to be here again.
It is. Yep.
Seeing all your smiling faces, all your shiny faces.
Yeah, we're super shiny today.
Yeah, you guys are super shiny. I see that.
Subtle.
So last week we ended with, we were working on some of the critics of the younger Dryas impact hypothesis.
Yeah, because I feel like we need to look at all sides of these kind of controversial ideas that are out there. Don't you? Don't you feel like we should? Yeah, we do. So, yeah, we were talking, I think we kind of ended up discussing the Boslough paper, the paper where he was invoking the Yang paper.
That's right.
To support his contention that there was no evidence for an impact because these microspherules were found in other soil horizons than the younger Dryas boundary. That was the contention of it. But when we actually went into the Yang paper, we discovered that they were pretty open to the idea that these microspherules were the result of a cosmic impact. So jump ahead a little bit, then we'll come back to the critics. Because as this research has gone on, more scientists, more geologists particularly, have gone back just very parallel in a way to the KT boundary, the Cretaceous Tertiary boundary, when the first iridium layer was discovered in Gubbio, Italy. Then the other groups, other teams went back and re-examined the Cretaceous Tertiary boundary. First, I know there was a re-examination in Denmark. There was another one in New Zealand. There was another one in Spain. And as a result of that, by going back and taking another look, they discovered the impact proxies. Very similar thing has happened with the younger Dryas boundary idea that there was an impact. So others have now gone and taken a closer look. In central Mexico, we're pushing the extent of the phenomena. We're widening the extent. We talked, I think it was last week, maybe the week before, we were talking about the evidence found on Santa Rosa Island, right? So this was a paper that was published in 2012. Isabel Alcantara, if I'm not butchering her name too much, I hope not. And the title of the paper, which was published in the proceedings of the National Academy of Sciences, was entitled Evidence from Central Mexico Supporting the Younger Dryas Extraterrestrial Impact Hypothesis. So what they did was they took a core from Lake Cuitzeo, I think is how it's said, something like Cuitzeo. Again, I'm probably butchering it, but it's fairly close to that. When they took this sample from the bottom of the lake, they were able to find the younger Dryas horizon. And we report the discovery in Lake Cuitzeo in central Mexico of a black carbon-rich lacustrine layer, lacustrine simply a fancy word for lake, right, containing nanodiamonds, microspherules, and other unusual materials that date to the early younger Dryas and are interpreted to result from an extraterrestrial impact. So they took out a 27-meter long core, which is close to 90 feet, as part of an interdisciplinary effort to extract a paleoclimate record back through the previous interglacial, which is generally considered to be the Eemian, which was back over 100,000 years ago. Usually invoked as being an interglacial period that's more or less parallel to the Holocene, the one we're in now. So she goes on to say our attention, and she was part of a whole team, our attention focused early on an anomalous 10 centimeter thick, so maybe 3 inches roughly, carbon-rich layer at a depth of 2.8 meters that dates to 12.9 thousand years ago and coincides with a suite of anomalous coeval environmental and biotic changes independently recognized in other regional lake sequences. Collectively, these changes have produced the most distinctive boundary layer in the late Quaternary record. Now that's really saying something, because if you're talking about the Quaternary, you're talking about 2.5 million years. So they say, again, I'll repeat that. Collectively, these changes have produced the most distinctive boundary layer in the late Quaternary record. This layer contains a diverse, abundant assemblage of impact-related markers, including nanodiamonds, carbon spherules, and magnetic spherules with rapid melting / quenching textures, right? So in other words, the surface melts and then quickly recrystallizes, right? All reaching synchronous peaks immediately beneath a layer containing the largest peak of charcoal in the core. That's pretty intense stuff right there. Now we're down in central Mexico with that. Let me show you. I'll do a screen share. Here's a
So what they mean by that is, I'm trying to get this right. You see all the impact proxies, and then directly above that is a whole bunch of evidence of fire.
Yes, yes, that's exactly it. Yes. So I will do a quick screen share here. We will see some. Here's the lake in central Mexico. Now, the lake itself, nobody's claiming that the lake was produced by the impact. Right. In fact, the lake, whatever the origin of the lake, it was already there. So the sediment that accumulates on the bottom of the lake, that's the key here. And let's see, you can't really see it on this map. It's right down here in central Mexico. If you can see my my cursor, it's right in this area. It's the second largest lake actually in Mexico. I think we can, do we find it here? It's I believe this is it right. I think this is it right here. So it's in central Mexico. So if you look at the large scale map, you can see we've suddenly moved the boundary of the Younger Dryas impact evidence. We've extended the range here down into Mexico.
Now you said this is the largest carbon spike in the Quaternary?
In the Quaternary.
Okay.
The term that she used is that it's the most distinctive boundary.
That's 250 million years.
No. 2.5 million years.
2.5 million years. Okay.
Yeah.
Well, and it did say late Quaternary, so I'm not sure where that's defined, the late Quaternary.
Well, I would say the late Quaternary, we would probably be extending back through the last interglacial anyway. So given that the whole Quaternary is 2.5 million years, we're probably looking at a couple of 100,000 years for the late Quaternary.
Sure.
Yeah. And, but what it does say is it contains the largest peak of charcoal in the core. So the team goes on to say, we have examined multiple hypotheses to account for these observations and find the evidence cannot be explained by any known terrestrial mechanism. It is, however, consistent with the younger Dryas impact boundary hypothesis, postulating a major extraterrestrial impact involving multiple airbursts. Airburst, now they have the S in parentheses so that you can read it as a single airburst or multiple airbursts, right? And slash or ground impacts at 12.9. What they don't say here, though, which to me is perhaps an omission, is the possibility of impacts into the ice sheet itself. And that's the thing that I want to be looking at more. And it's certainly part of several of the scenarios, because there's not just one variation on this impact hypothesis. There's several variants. In fact, that's one of the things that the critics have jumped on. They say, well, there's not a single coherent hypothesis here. But, you know, it's just like, again, going back to the Cretaceous Tertiary back in the early 80s, there was, of course, not one single hypothesis. You discover this layer of iridium, an anomalous iridium layer. So then you begin to speculate, right? You begin to hypothesize. So you have to test those hypotheses. As you'll see that the critics have tried to use the actual scientific method to somehow discredit the idea, because right from the very start, there wasn't some coherent model that everybody agreed upon. So then the Alcantara paper goes on to say that the Surovell paper, which I'm going to come back to in a second, reported finding no younger Dryas boundary microspherals, magnetic spherals, no peaks of magnetic spherals, although they claimed to follow the protocols of Richard Firestone and his team, which they laid out very explicitly how they step by step went through these sedimentary samples that they were looking, these aliquots, and were able to then filter out the non-impact material, because the impact material, you're talking about maybe a few hundred parts per million, right? So it'd be very easy to get lost if you don't have the proper procedure in place to isolate that stuff. You see what I'm saying?
Their sieve was too big or something. Their sieve was too large.
That was one of them. That was one of the factors. I'll come back to that just a second, because that is one of the things that Malcolm LeCompte's paper addressed, was how they the sieve that they used, because right, if the apertures are too big, it's because the things you're looking at are extremely small, see? So, I mean, you've got to use a sieve that's very small, appropriate, you know, of corresponding size. Otherwise, too much stuff comes through. And now you've got to filter through too much stuff to find the little, the magnetic grains and the nanodiamonds and so on. So the Alcantara team goes on to say that that the Surovell paper concluded that the Firestone team misidentified or miscounted the microspherals, the magnetic spherals. Later, Malcolm LeCompte and his team independently examined two younger Dryas boundary sites common to Firestone and Surovell, right? They reported that, here's quote, spheral abundances are consistent with those of Firestone et al. And inconsistent with the results of Surovell et al. They also concluded that Surovell et al. Altered the prescribed magnetic spheral protocol in fatal ways, particularly by not observing requirements for sample thickness, sample weight, and size sorting. We consider these discrepancies significant enough to negate the conclusion of Surovell et al. Let's go to the Surovell paper. This is Todd Surovell et al. published in the Proceedings of the National Academy of Sciences in 2012. He says, herein, we report the results of an independent analysis of magnetic minerals and magnetic microspherules from 7 sites of similar age, including Blackwater Draw, New Mexico, and Topper, South Carolina, both examined by Firestone et al. In all 7 sites, we found no distinct peak in magnetic grains or microspherules uniquely associated with the younger Dryas, and therefore find no support for an extraterrestrial cause of the younger Dryas event and New World Pleistocene extinctions. Okay. So they go on to say in both of the resampled sites, okay, resampling going to the sites presumably where Firestone team took their samples, and our additional sites using methods taken from Firestone et al., we failed to reproduce their results. We have found no peaks in magnetic particles or magnetic microspherules unique to 12.9 thousand year ago level in any of our sample sites that were significantly different from peaks in these materials at other levels in the stratigraphy. The situation is the case even at Blackwater Draw, where our samples were collected within a few centimeters of the sections previously sampled. Assuming an ET impact occurred, now this is I think this is fair on what they're now saying, and because they're leaving a little crack in there, and sort of a tacit admission, right? They say, assuming an ET impact occurred, perhaps the lack of reproducibility indicates that the methods used for recovering the magnetic material are not appropriate for the task at hand. So then Boslough, back to Mark Boslough, he says, magnetic microspheral abundance, and this was published in Climates, Landscapes, and Civilizations, part of the Geophysical Monograph series. Magnetic microspheral abundance results published by the impact proponents have not been reproducible by other workers. Analysis of the same younger Dryas site stratigraphy by Surovell et al. Could not replicate observations for 2 of the impact markers published by Firestone. The study by Surovell et al. Found no peaks of abundance unique to the younger Dryas time interval. So now, what happened is the Surovell paper pretty much became the basis upon which all subsequent refutations of the younger Dryas impact hypothesis were based. His team's inability to replicate the work of the Firestone team that was published in 2007. Is this making sense so far? Yeah. So I can actually go here. Let's see.
It doesn't make sense, though, is if all they're saying is that they couldn't replicate the peaks and that the microspherules that they did find were not irregular or like were no different than anywhere else in the stratigraphy, how would a sieve size result in that? Because if they're using the same size sieve, but they're finding...
we'll address that. I want to show you this though, so you see how it works. I'm going to do a screen share.
It even sounded to me like, well, they did it within a few centimeters, but sometimes that boundary may be only a centimeter thick. So if they're a few centimeters off, yeah, they're going to miss it. Yeah.
Okay, so this is now for how mainstream media covered this. You see this? Experts find no evidence for a mammoth killer impact. A devastating cosmic collision 13,000 years ago continues to play well in the media, but specialists are challenging the grounds for thinking it happened. So it's a good thing now that the experts have weighed in, because Douglas Kennett and James Kennett and Alan West and Wendy Wolbach and Richard Firestone and Chris Moore and these people are apparently not experts. Yeah. Ted Bunch is not an expert. Okay. So that there was one example. Let's see here. Here's another one. Comet impact theory disproved. New data published today disproves the recent theory that a large comet exploded over North America 12,900 years ago, causing a shock wave that traveled across North America at hundreds of kilometers per hour and triggering continent-wide wildfires. So here, this is interesting. Dr. Sandy Harrison from the University of Bristol and colleagues tested the theory by examining charcoal and pollen records to assess how fire regimes in North America changed between 15 and 10,000 years ago, a time of large and rapid climate changes. Their results provide no evidence for continental scale fires. Now, bear in mind, they're just looking at basically one site, but support the fact that the increase in large-scale wildfires in all regions of the world during the past decade is related to an increase in global warming. Ooh, surprise, surprise. Okay, do you see how there's an important indicator here that there's politics at work?
Agenda.
And now, interestingly, though, here, look what they say here. They found clear changes in biomass burning and fire frequency whenever climate changed abruptly, and most particularly when temperatures increased at the end of the Younger Dryas cold phase. So right there, you see what's happening? When the climate changes, they're seeing an abundance of fires. Well, why would that be? Well, multiple reasons. One reason would be, of course, when you have abrupt, large-scale, or catastrophic changes in climate. And these are just not happening. There's something driving that. That's the point, right? But when you have a large-scale shift in climate, what happens to the vegetation that is adapted to that particular climate that suddenly is completely different? It dies off. When it dies off, what does it do? It creates the basis for large-scale fires. See, that work didn't disprove anything, really. All it did was confirm that, yeah, there are other episodes of very large-scale fires that have occurred and left their mark. However, as the Alcantara team pointed out, in their particular core sample that they took from the bottom of the lake, that layer, like they said, is the most distinctive layer of the late Quaternary and the largest charcoal deposit that they found in the entire core. So anyways, I think we should just continue on here. So going back to Boslough, so now you see basically that what has happened here is that, you know, it's almost like you have this faction that is ready to jump on anything that relieves them of having to address this heresy. The heresy being, yeah, planet Earth got its ass kicked 12,900 years ago, which the scale and magnitude of the event would have profoundly affected the human species. Unlike the Cretaceous Tertiary event, this was one where humans participated in this phenomena. And that's the most critically important insight, I think, to take away from this, because when we look at you know, basically the rise of what we consider modern history, right? What do we see? I mean, we see, you go in and you do the research into the dispersal of languages, right? And we're back to 10,000 years ago. If we talk about the general domestication of animals, the beginning of agriculture, the first cities, we're looking at 8 to 10,000 years ago, aren't we?
And it's not just that humans participated, but that they were victims as opposed to instigators. That's another thing.
Yes. Yes. Exactly. So going back to you know, what we were talking about last week, where the Boslough team was attempting to discredit the idea by saying these proxies are found in other levels as well, which is true. However, are they dispersed? Are they more widely dispersed, or are they found in the same levels of concentration that we see at the YDB, the Younger Dryas boundary? So at the end of the last episode, I asked this question: how do these results, the results of Yang, and if you haven't seen that episode, you should get back and watch that. How do these results negate the findings of Kennett and others, as the Boslough team implies? The fact that the spherules were found in more recent sediments, Boslough and others try to use to discredit the work of the Kennett team. But now I ask you to consider this carefully. The fact that the Yang team found spherules containing nanodiamonds in more recent sediments than the Younger Dryas boundary means, according to Boslough and his guys, that, quote, they were evidently not produced by impact processes because they are present in modern soil and lack any links to impact structures. Again, how is this conclusion in any way supported by the findings of Yang et al. When they actually invoke impact as a plausible explanation? So then I asked the question, what are these impact-produced spherules doing in recent soils? And I would suggest that the findings, and these were from samples taken in Germany and Belgium, okay, that the other way of interpreting it is if there's other horizons with, with what are clearly identified as impact proxies, does not disprove that you had an impact at the Younger Dryas boundary, but simply provides evidence that maybe impact events are far more frequent than have been previously recognized.
Right.
Last week we talked about the other possibilities as redeposition.
Yeah.
Redeposition,
and
exactly.
Of course, not finding a crater doesn't mean that the crater doesn't exist.
Yeah.
Right,
So-
right.
No known structure
Right.
is
Yeah.
different. No
Yes.
structure exists.
So then they also talk about another paper, TIAN team, again, the Proceedings of the National Academy of Sciences, published in 2011. They studied the YD boundary in Belgium. And that particular team was referenced actually by the Alcantara team, who were studying the core samples from the bottom of Lake Huzio. So anyways, Boslough, looking at Alcantara's work, who referenced Tian or Tian, if you can follow this now, state that Alcantara and others quote Tian or Tian et al. As independent confirmation of cubic nanodiamonds in Younger Dryas boundary sediments. However, they do not mention that only a limited range of sediment horizons above and below the Belgium Younger Dryas boundary were studied in that work. Okay.
Okay.
Yeah. Okay. And so what? I got to ask that further. And going on with the quote here, further, they do not mention the results of Yang et al., which taken together with Tian et al. Suggest that nanodiamonds may be distributed throughout the Belgian sediments. So now they're bringing the Yang team's work back in, which we've already addressed, and shown that it does in no way refute the idea of an impact, and in fact actually supports it. Okay, so now,
So is their problem? They're trying to point. Are they trying to imply that because they didn't check everything, that's why they're like saying, well, what if they're everywhere? You guys didn't actually look.
yes, that's what they're saying. Okay, so the Tian team made a study of a thin black layer that was about 20 inches beneath the surface near, I don't know how you say it, Lommel, Lommel, Belgium. So they begin their paper by briefly describing the history of the impact controversy, mentioning two critics of the Younger Dryas impact hypothesis, Paquet, who in substance is not much different than Surovell, and Surovell. Tian and others point out that these two teams failed to replicate the findings of the impact proponents. The electron microscopy data put forward by the Kennett team, this is Kennett, West, Firestone, these are the proponents, right, demonstrate the presence of Lonsdaleite at the Younger Dryas boundary. And the Tian team claims that this is unconvincing. But then they go on to state, with regard to the report of the Kennett team, although, and I'm quoting now, although the reported lattice parameters this is how the lattice parameters is how you identify a crystal, can indeed be assumed to originate from Lonsdaleite. Low precision measurements from ring patterns resulting from small particles can at most be seen as a first indication. So basically what they're saying is that the hexagonal nanodiamonds that was identified by the Kennett team, they're not convinced by it. Sure, fair enough. But they're also admitting that, well, this is only a first indication. And that would probably be exactly what the Kennett team would say too. That it's a first indication, and we need more studies, a bigger sample base. But it can readily be seen that TN and others does not exclude the possibility that the Kennett team did in fact discover Lonsdaleite. And Lonsdaleite is a very definitive proxy for impacts, right? And actually gave a half-hearted support to the interpretation. When they get to the subject of their own findings, TN and his team report that, and I quote now, "Our findings confirm and in fact reveal more direct proof than the earlier studies for the existence of diamond nanoparticles also in this European Younger Dryas boundary layer." Now, last sentence of the quote, "No such particles are found in the overlying silt and clay or in the underlying fine sands." So in other words, they did look at the contiguous layers. Here's the boundary. They looked in the layers above, they looked in the layers below, they didn't find them, but they did find them right at the Younger Dryas boundary. Now go back and think of what Boslough said. You see, what we're getting. Yeah, he misrepresented it. He misrepresented their work.
There were no spikes at the boundary.
Yeah.
And there obviously were.
Yeah. So again, I have to ask, how is it that the work of Yang et al. And Tian et al. Disproves or even discredits the findings of the Kennett team? Is it beginning to appear that we're witnessing a contrived attempt to discredit the findings of the Kennett team? And returning to the work of Isabel Alcantara and her 15-member team, we find powerful independent corroboration of the work of Firestone and others. Their paper describing research that supports the impact hypothesis was published in March of 2012. So their sample that they were studying was 88.5 feet long, 4 inches in diameter, right? 4 inches, 88.5 feet long. And it provided a detailed record of regional environmental and climatic changes back to 130,000 years. So by the time this article was published in 2012, some of these challenges from these other workers had now come in and were being directed at the Younger Dryas impact hypothesis. So the Alcantara team therefore make it clear that, and I'm quoting from their paper, because of the controversial nature of the Younger Dryas impact debate, we have examined a diverse assemblage of YDB markers at Lake Cuzio using a more comprehensive array of analytical techniques than in previous investigations. In addition, different researchers at multiple institutions confirmed key results. So amongst those comprehensive array of analytical techniques, without going into the methodology, you had transmission electron microscopy, you had high resolution transmission electron microscopy, you had accelerator mass spectroscopy, you had energy dispersive X-ray spectroscopy, you had fast Fourier transform analysis, and electron energy loss spectroscopy, or EELS. Suffice it to say that these technologies allow of the highest precision and accuracy for the identification of the relevant materials. So they went all out to try to determine, right? So the thing that first caught their attention that led to all of this was the anomalously high amount of charcoal that they found there. So they concentrated on counting charcoal microparticles between the depths of 11.8 and 7.2 feet in depth. So this interval dates from approximately 21,000 to about 10,000 years ago, right? So you got 11.8 feet down, which is going to be the lowest, the oldest, right? And then it's 7.2 feet. So now you've got 21,000 years ago down here, 10,000 years ago here, okay? The background level of charcoal particles was about 5,000 particles per kilogram of sediment. So this is diffused throughout that several feet there, right? So at a depth of 3.1 meters, which is just a little under 10 feet, dating to about 16,000 years ago, they found a minor peak of 29,000 particles per kilogram. Okay, so background throughout, you just sample randomly, 5,000 particles per kilogram is what they were able to isolate. So at the 3.1 meters, 16,000 years ago, they found a peak, a spike of 29,000 particles per kilogram. When they looked at the onset of the Younger Dryas boundary, which was at a depth of 2.65 meters, they found a peak of 77,000 particles per kilogram, or 15 times greater than the background count. This, the authors attribute to, and I quote, a major episode of biomass burning. This peak in charcoal particles is found about 5 centimeters above a layer containing magnetic spherules, carbon spherules, and nanodiamonds. So it appears that at this location, there was a major episode of biomass burning, followed immediately by deposition of 3 unique types, or that followed immediately the deposition of 3 unique types of impact proxy material. Then they also pointed out that their Lake Yaguada, again, I might be butchering the name, Leyguada in Panama. They discovered that there's also a major peak of charcoal particles that date to the onset of the Younger Dryas. So, quoting the team again, for Lake La Yaguada, although the Younger Dryas episode was not expressly identified, the workers there did recognize a major abrupt environmental and ecological change, which they referred to as a time of crisis, close to the onset of the Younger Dryas at approximately 12.8 thousand years ago. This is reflected in dramatic changes in the pollen and diatom records, biotic turnover, clay mineralogy, sedimentary geochemistry, and particulate carbon flux. So these 2 lakes are separated by about 1,500 miles. So right there you can see, well, biomass burning dating to the same point, deposition of impact proxies, 1,500 miles apart. And now we're finding the same stuff up in North America. We've reached as far south as Panama. So the author's right. In summary, from widely separated lakes in the highlands of Costa Rica, let's see. Okay, so let me point out though first that this is that not only in Lake Cuzio and Lake La Yaguada, there are other lakes as well. Okay, that the authors don't get into in detail, but they mention them. And so, in summary, they write that from widely separated lakes in the highlands of Costa Rica to the lowlands of Guatemala and Panama, there is only one stratigraphic interval that displays extraordinary environmental and biotic changes, and in each case, this interval occurs at or near the Younger Dryas onset. So,
I know this is sort of an aside, but it's just as you're talking about all this, I'm just imagining sort of in fast forward all of the deposition in these lakes over the years. You know, I mean, the cores that they had, what did you say, 150,000 years?
Well, this particular 28 or 88 foot long core
Yeah.
Covered 130,000 years.
130,000 years. I don't know why, but I was just having an image in my mind of this, and it's like, it's just really fascinating that there's this forensic evidence just being laid down of all of this.
Yeah, lakes
history
are like
of the
lakes are
world,
like
like-
perfect capture devices
Yes.
for this
Well,
kind of
they
stuff.
are. Yes, they are.
It's just
Very
fascinating.
much
It's really cool.
like tree rings almost, because you have seasonal deposition in the lakes,
Right.
annual deposition that's very clearly can be identified.
I was thinking
layer
like all
after
the
layer.
leaves in the fall landing on the lakes, sinking to the bottom,
Yeah.
all of
Yes.
the fish and the cycles that the animals go and through every year.
Right. The rainy periods where you have
Yeah.
much more material flushed into the lakes. Yes. So
Right.
you can look at a sequence and it'll be
See the
quite
pattern.
regular.
And then you
now-
see breakups of the pattern, and
Then you see interruptions of the normal pattern. So right there, that should be something that gets your attention, and it does. They
Yeah.
look at it, and
so fascinating.
it totally is. I mean, it's very much detective work.
Yeah.
Looking at clues, and this is why I've used kind of the analogy of footprints and fingerprints. Footprints you can see with the naked eye, right? They're like things that you can see in the landscape. A coulee would be a footprint. A dry cataract would be a footprint. An erratic iceberg rafted boulder, a footprint, right? A huge boulder bar, a footprint. Fingerprints are the things that you have to have technological assistance in order to detect. So
Right.
that would include the nanodiamonds and the magnetic grains and the microspherules and the iridium spikes and so on.
Right. And the crater is like the murder weapon.
The crater is
smoking gun.
the crater is the smoking gun. Absolutely. Absolutely. And in fact, it was the discovery of the Chicxulub crater in Mexico that pretty much finally got the most of the critics of the KT impact hypothesis to shut up. Although, again, it's not as clean as you would like, because one of the primary things, and this same criticism applied to the Younger Dryas impact idea as applied to the Cretaceous Tertiary impact idea, that, well, it seems like there were like some losses of species that were, before the actual impact boundary where the iridium was found. Likely true. However, when we begin to look at the planet, what we have to understand, just like what's going on now, for several days down in the Philippines, we've been now having this volcanic eruption. Leading up to it, you had tremors, you had things that you had things happening, right? In the aftermath, you have things happening, and that's the point, is that no, you can't just oversimplify these things, to say, see, here's the assumption. Well, if it's an impact, it's just this one thing, boom, that's all done, it's over with. So there would only be one horizon where something actually should have happened. But what that is an oversimplified model of the impact evidence and the impact ideas. And just like at the KT boundary, there's evidence that we had a what would I call it, an impact epoch, a period where you had multiple impacts. Now, the Great Chicxulub crater would have been most likely the greatest and had the most profound effect. But, even something that leaves a crater 10 miles in diameter as compared to the 130 or 150 miles that the Chicxulub crater is, even an impact event that leaves a 10-mile crater is still going to have a global impact. It's still going to affect the climate. It's still going to have maybe not global extinctions, but certainly regional disruptions, regional, maybe even continental-wide extinctions. So the fact that you might look in 50,000 years before the actual iridium layer, there appears to have been some disruption, then does not negate the impact at the KT boundary any more than finding that there was an event that happened at 14,006 negates the possibility of an impact at 12,900.
Yeah.
So then we get to the Lecomte paper, And let's just do a screen share here.
I also think that we don't really know what is a I've said this before. What's a normal rate of extinction? We just don't have enough data to say anything about that yet, right? Like, how often are things going extinct all the time? What could we say that there's a normal rate of?
Yes, there has been. Yeah, the gradualist models will say that any given time, roughly 10% of the species are in the process of going extinct.
Okay.
10% of species, replacement species, are in the process of evolving to fill those, those vacated niches in the biosphere. That's good. And I'm not saying that that's not going on, right? But the whole point of, like, going back to Stephen Jay Gould with his idea of punctuated equilibrium, is that normal pace of change gets interrupted from time to time. And really, those interruptions are where the action is.
Right. And what's the rate of that 10% die-off and replacement? What kind of time span are we talking here? Millions of years?
Well, ongoing. Like, it's an ongoing process.
Right. So 10% is going extinct over millions of years? Is that what they mean? You know what I'm saying? That's what I'm talking about.
Pretty much, yeah.
Okay. So no one's going extinct in short time spans.
Right. Although we have seen extinctions in the last 2 centuries.
Yes, we have.
And we need to talk about that, because it's important to understand how those extinctions occurred and why they occurred. Most of them were insular. Species that had a very limited habitat, such as on islands.
Specialized,
very specialized. And it was the introduction mostly of invasive species that pretty much then became competitors for the ecological niches of the species. And it was in the competition.
But
go ahead, Kyle.
The 10% thing is still a wild guess.
Yeah.
Because we're still, we're in the process of discovering new species of bugs and whatnot all the time. We have no idea what's going on in the bottom of the ocean everywhere.
Mm-hmm.
So it's
like the depths of the jungles in a lot of places.
Right. It's how.
Well,
what it does, like it's going to be a wild guess, no matter what.
Here's, to me, the value of the whole uniformitarian paradigm. It gives us a baseline from which to work. And it also gives us a context for understanding the things that have not happened gradually, you see.
Okay.
And the problem is it's become, it became dogma, like we talked about. It's become dogma in the late 19th, early 20th century, and anything that departed from that dogma was considered to be pseudoscientific, or, hey, you're trying to bring the biblical literalism back. They were afraid of the Noah's flood scenarios. They were afraid of the young earth people, the 6,000 years. And, I would say I can't blame them for that. But, like we said, I think last episode, they threw the baby out with the bathwater by rejecting, any departure from the uniformitarian model. And this is why J. Harlan Bretz met with such resistance when he proposed his catastrophic flood hypothesis in the 1920s.
Yeah.
So then, as a result of the independent evaluation by the Surovell team, we had another independent evaluation that followed on the Surovell team, led by Malcolm Lecomte, along with Albert C. Goodyear, Mark Dimitrov. Now, Brad will remember Goodyear. We went down and we toured the Topper site with Al and Graham Hancock. What was that, 2 years ago now? A year?
Right. Too close.
Somewhere like that. And then we participated in a roundtable discussion there at I think the George Howard set up, beautiful, whatever that was, golf course resort. And Mark Dimitrov, one of the authors of this, was there. Let's see, who else? Nobody else. So Malcolm was there, Al Goodyear and Mark Dimitrov, they were all there. And we had a great discussion, good time. We went out in the field with Al and got to see the Topper site. So we'll probably be sharing photos of that, although Graham Hancock gets into that, a discussion of the Topper site in America Before, which if you haven't read it, that would be a very good read. And if you haven't read Magicians of the Gods, he gets into the Younger Dryas hypothesis in there and goes into some good detail. And he's a good writer, so it's an entertaining read.
And both are available as Audible books read by him, which are fantastic. So for people who don't have time to read as much, those are great as well. So
yeah, like listen to it when you're driving or whatever.
That's right. Yeah.
Right.
We also had Chris Moore that joined us.
Right.
At Topper, and then took us to a Carolina-based site, and then Mike was actually with us there that day also.
That's right.
Yeah, we had a crowd, though he wasn't at Wilmington. More of those guys' evidence are going to keep coming forth here as we get into Chris Moore too. Yeah,
and Chris Moore, great guy, and I would say one of the leading proponents of the Younger Dryas impact, who, according to what he told me, he started out as a skeptic.
Right.
Yeah. So now here's what the LeCompte paper says in the abstract. Firestone et al. Sampled sedimentary sequences at many sites across North America, Europe, and Asia. In sediments dated to the Younger Dryas onset or boundary, YDB, approximately 12,900 calendar years ago, Firestone et al. Reported discovery of markers including nanodiamonds, aciniform soot, which is a type of soot that forms in catastrophic wildfires, high-temperature melt glass, and magnetic microspherules attributed to cosmic impact airbursts, which, of course, invokes the scenario of Tunguska, which was an airburst. The microspherules were explained as either cosmic material ablation or terrestrial ejecta from a hypothesized North American impact that initiated the abrupt Younger Dryas cooling. It contributed to megafaunal extinctions and triggered human cultural shifts and population declines. A number of independent groups have confirmed the presence of Younger Dryas boundary spherules, but two have not. One of them, Surovell et al., which we have been talking about, collected and analyzed samples from 7 Younger Dryas boundary sites, purportedly using the same protocol as Firestone, but did not find a single spherule in Younger Dryas boundary sediments at 2 previously reported sites. To examine this discrepancy, we conducted an independent blind investigation of 2 sites common to both studies and a 3rd site investigated only by the Surovell team. So what did they find? We found abundant Younger Dryas boundary microspherules at all 3 widely separated sites, consistent with the results of Firestone et al., and conclude that the analytical protocol employed by Surovell et al. Deviated significantly from that of Firestone et al. Morphological and geochemical analysis of the Younger Dryas boundary spherules suggests that they are not cosmic in the sense of the steady rain of cosmic particles, which is what Boslough and some of the critics have been saying, is that these things are part of the steady, uniform accretion or raining upon the earth, and not indicative of a singular event. So instead, they appear to have formed from abrupt melting and quenching of terrestrial materials. So
I don't know when this happened, but wasn't there a similar paper that was trying to claim that the melt glass could be made in like campfires and stuff? There was
campfires wouldn't be hot enough to make melt glass.
Fires or something like that. Yeah. Burning of villages.
Yes,
because all these sites were at paleo, Clovis sites and stuff where they were actually digging and finding this stuff. The claim was that the burning,
was human intentional,
right?
Making the melt glass. There was a paper about that. They were digging in Syria, looking at some stuff in Syria.
Oh yeah, I remember that. Well, that would be a good thing to address at some point.
But house fires will not make nanodiamonds. So
normal house fires will not make nanodiamonds, no.
Yeah.
Nope, they won't.
If they did, we would all have a lot of diamond.
This is Kosmographia, the Randall Carlson Podcast.